Okay, now for question 15. It says a particle is moving with a velocity of velocity equals 16 minus 4t centimeters per second. So we've got velocity equals 16 minus 4t centimeters per second on a horizontal number line, and we've been asked to find acceleration and displacement. So in part A, remember acceleration is dv dt, which is just differentiating that, which is -4. That will be centimeters per second. And x will be the integral of 16 minus 4t with respect to t, which is 16t minus 4t squared on 2, plus c, which is 16t minus 2t squared plus c. Now, so we've got functions for acceleration, which is -4 centimeters per second, and displacement. Now, it says, when does it return to its original position? So, and what is its speed then? This is a concave down parabola. We don't know what the plus c is, okay? So I'm going to draw this, actually what I'm going to do, I'm going to factorize this, and I'm just going to ignore this plus c, okay? So if I take out 2t as a common factor and I get t minus 2, sorry, no, what's wrong with me? Take out 2t as a common factor, sorry, and I get, factorizing, I get 8 minus t plus c. Now if I want to, let's say for example c is 0, this would be a concave down parabola, and the t-intercepts would be 0 and 8, okay? So that's if c was 0, it would look like this. Now it doesn't really matter what c is. If c is 2, then this would all shift up 2. Now the starting position is here, and we just want to know when does the particle return to its starting position, and it will be at time equals 8. Now it doesn't really matter, actually I'm not going to put this as the axis, I can just put that that's c. Okay, just even with a dotted line, that would be my constant there. Okay, so my axis actually could be down here somewhere, it wouldn't matter. But I know that I get back to the same position of x, regardless of what c is, when t is 0 and t equals 8 gives me the same position as when I started. So for part A, for part B, the particle, and that's for this bit here, the particle returns to its starting position when time equals 8 seconds, okay? And it says, what is its speed then? We just substitute t equals 8 when into v, okay? So substitute t equals 8 into the formula for v, and we get v equals 16 minus 4t, so 16 minus 4 times 8, which is 16 minus 32, it's negative 16 meters per second, so therefore the speed equals 16 meters per second, but it's in the negative direction, so that's what the negative is for that velocity. So it's travelling at 16 meters per second, but it's just travelling in the negative direction. Now for part C, when is the particle stationary? Now the particle is stationary when velocity is 0. Now we can look at it from this graph here, and halfway between 0 and 8 is when t is 4, or we can substitute v is 0 into this equation and you'll get t is 4 as well. So I'm going to put v equals 16 minus 4t, so 0 equals 16 minus 4t, and so therefore t equals 4 seconds. So that is when the particle is stationary, at t equals 4 seconds. Now it also says find the maximum distances right and left of the initial position during the first 10 seconds and the corresponding times and accelerations. Now, if we look at this graph of x versus t, remember velocity equals dx dt. And from time equals 0 through to 4 seconds, velocity is positive because the gradient of this curve is positive. And from time equals 4 seconds onwards, velocity is negative. And from t equals 4, I'd say through to 10 seconds, they want to know about the first 10 seconds, the velocity is negative. Okay? So, in other words, from t equals 0 to t equals 4 seconds, the particle's moving to the right. And from t equals 4 seconds to 10 seconds, the velocity is negative, so the particle is moving to the left. And we can see that here. This is the starting position, and you're getting larger values of x, so you're moving further and further to the right. And then you're getting closer and closer. Your values of x are getting smaller, and you're moving further to the left all the way down here. Okay? Now, because this is symmetrical, the area under there will equal the area under there. So the area from t equals 0 to 4 equals the area from t equals 4 to 8. Okay? So we know that the area from, or you could even, sorry, I shouldn't be looking at areas, that's an x curve. We know that we travel up to this displacement and then we come back to the origin. You'll be furthest to the right of the origin of the initial position at time equals 4 seconds. So at t equals 4 seconds, you are furthest to the right of the initial position. So you are furthest to the right of the initial position. Now, at t equals 8 seconds, you're back at the initial position, okay? So at t equals 8 seconds, you are at the initial position, and you keep traveling in that left direction, in that negative direction. So therefore, at t equals 10 seconds, you are furthest to the right, to the left of the initial position. So at t equals 4 seconds, you're furthest to the right of the initial position. T equals 8, you're at the initial position, and t equals 10, furthest to the left. So, but what are the maximum distances, right or left of the initial position? So at t equals 4, x equals, going up to the equation here, 16t minus 2t squared plus c, x equals 16t minus 2t squared plus c, which is 16 times 4 minus 2 times 4 squared plus c, which is 64 minus 32. You're 32 plus c, so therefore you are 32 meters to the right, centimeters to the right of c. And at t equals 10 seconds, x is 16 times 10 minus 2 times 10 squared plus c, so it's 160 minus 200, which is negative 40 plus c. Therefore, you are 40 meters to the left of c at t equals 10 seconds. So our units are centimeters, so 40 centimeters to the left of c. Now looking at this is part C still, and the corresponding times, we've got those, but the accelerations. So acceleration, we know is, constant negative 4. So therefore acceleration is negative 4 meters per second, which means therefore it's 4 meters per second, acting always to the left, okay, or in the opposite direction of the initial position, which is acting to the left. So it's a constant 4 meters per second, acting to the left at all times. Okay, so that's part C. And now for D, sorry, just a bit out of order on the page. It says how far does it travel in the first 10 seconds? So how far does it travel in the first 10 seconds? Well, we've got a bit of a picture here. We know that at time equals 4, it's 32 centimeters to the right. At time equals 10 seconds, it's 32 centimeters to the right of C. At time equals 10, it's 40 centimeters to the left of C. We better see where it is at the beginning. So at time equals 0, we get x equals C, so therefore it is at C. So, sorry, at time equals 0, not time equals 10. So at 0 time initially, the particle is at C. So therefore, this is what happens. It starts at C. It moves, it's got a positive velocity for the first 4 seconds. Also, sorry, something I didn't mention up here, gradient 0, velocity is 0 at 4 seconds. So it moves to a position that is 32 centimeters to the right of C at 4 seconds. And then it stops because velocity is 0 at 4 seconds, and then it turns around, and at 10 seconds it ends up being, so it's gone like this, moved 32 centimeters, and then it's ended up being 40 centimeters to the left of the origin. So therefore the distance travelled is 32 centimeters plus 32 coming back and another 40, plus 32 plus 40, which is 64, which is 104 centimeters. Now, therefore, its average speed is its distance travelled over time. So it's travelled 104 centimeters in 10 seconds. So therefore, it's 10.4 centimeters per second is its average speed. This is exercise 4C. It's question 16. It says a particle moves from x equals -1. That means when t equals 0, x is -1. And it's saying it moves with the velocity of 1 over t plus 1. Okay? Now, we have to find the displacement and acceleration functions. Let's do acceleration first, which is dv dt. Now, to differentiate that, you need to write it as t plus 1 to the power of -1. So differentiating, we get -1 t plus 1 to the power of, decreasing this by 1, we get -2, times differentiating inside, we get 1. So therefore that is -1 over t plus 1 squared. So that is the function for acceleration, which is fine. Now, again, v equals 1 over t plus 1. We have to find the displacement function. Now, x equals the integral of 1 over t plus 1 dt. So this is in the form of a fraction integrating a fraction. So if function of x equals t plus 1, then f dashed x equals 1. And this is in the format of f dashed x over fx. So therefore the integral of that is ln of the function of x plus c. But we know that when t is 0, that x is -1, so we get -1 equals ln 0 plus 1 is ln 1 plus c. We know that ln 1 is 0, so therefore c is -1, which gives us the function for x, which is ln t plus 1 minus 1. Find how long it takes to reach the origin. So when x is 0, you have to find the time t, and we get 0 is ln t plus 1 minus 1. So therefore we get 1 equals ln t plus 1. Taking e of both sides, we get e to the power of 1 equals t plus 1, and so therefore t is e minus 1. So it takes e minus 1 well, we don't really know what the units are, okay? And so it's e minus 1 units of time. And so that's how long it takes to reach the origin. We need the speed and acceleration there. So we'll just substitute t equals e minus 1 into the velocity equation, which is v is 1 over t plus 1, which is 1 over e minus 1 plus 1, which is 1 on e, is your velocity. That's units per... Look, if this is seconds, they just haven't given us units, so we can't really state units, all right? So that's the velocity. And acceleration we know is negative 1 over t plus 1 squared, so it'll be negative 1 over e minus 1 plus 1 squared, so the acceleration at that time will be negative 1 on e squared. The subsequent motion is to say what happens to the particle after this time. So let's just look at the equations that we've got. We've got x equals ln t plus 1 minus 1. So therefore, as t, I suppose, approaches infinity, you'll need your calculator for this. So just ln of a large number minus 1. Look, as t gets quite large, x gets larger. So x will get larger, but it gets larger fairly slowly, but it still is getting larger. So therefore, x approaches infinity. So therefore, the particle will approach infinity. We know that velocity is 1 over t plus 1. So therefore, as t gets larger, approaches infinity, we'll get 1 over a very large number, then the velocity will approach 0, but it will never become 0. So the particle will slow down. And we know that a equals negative 1 over t plus 1 squared. And as t approaches infinity, we'll also get the acceleration will approach 0 as well, because we'll get negative 1 over a very large number, which will give us a number very close to 0 as well. But it will slow down, acceleration will be negative, velocity will be positive, we'll always get a positive value here, the particle will be slowing down, but the acceleration will never equal 0. And if one were to sketch the function, ln t plus 1 minus 1, the ln curve looks like something like this, but we know that ln1 is 0, so this would be, it would look something like this, but then it's shifted down. It looks something like that, okay? Something like that. But as time goes on, like if this is x and t, as time goes on, it's getting flatter and flatter. So velocity is approaching 0. And velocity is getting flatter and flatter, but it's still not constant velocity. So the acceleration's very, very small, and it's approaching 0 as well. But it'll never become 0, okay? 17, a mouse emerges from his hole and moves out and back along a line. So that's the mouse hole. Mouse comes out, goes back in, comes out, goes back in, etc. So velocity equals 4t, t minus 3, t minus 6, which is equal to 4t cubed, minus 36t squared plus 72t centimeters per second. First question is to find the displacement. So x is the integral of velocity. So we'll do the integral of this one, it's easier. 4t cubed minus 6t squared plus 72t dt. And you will get 4t 4 on 4 minus 6t cubed on 3 plus 72t squared on 2 plus constant. Now, which is t to the power of 4 minus 2t cubed plus 36t squared plus c. Now we've got to assume that when time is 0, x is 0, that he's just emerging from his hole at time is 0. That'll give us that c is 0, therefore x equals t to the power of 4 minus tt cubed plus 36t squared. Now we can factor out a t squared. And we'll get t squared bracket t squared minus 2t plus 36, and this can be factorized as well, because the factors of 36 that add up to -2, we've got 6 and 6 which don't, 9 and 4 which don't. Sorry, just a little error, that's 36, that's 36, that's 12. So this is 12, sorry, that's 12. That's better, so we get t minus 6 squared. So therefore, sorry about that, therefore x equals t squared bracket t minus 6 squared. And the next question is when does he return to his original position, and how fast is he going then? So we want to substitute x equals 0 to find t, and we get 0 equals t squared, t minus 6 squared. So therefore t equals, at time is 0 and time equals 6. So therefore he returns to the original position at time equals 6 seconds, and it says how fast is he going. So when t equals 6, just substitute into the velocity equation, we get v is 4 times 6 bracket 6 minus 3 times 6 minus 6. Well, that gives us 0 by the looks of things. So I've just put it into that factorized form up here because I thought it's just much easier to work it out, and we get 0 meters per second. So when he gets back to the hole after 6 seconds, so here is the hole, he goes out and comes back. So, and then he stops when he comes back. Okay, so it says how far does he travel during this time. Now displacement is or distance travel, sorry, is the integral of the velocity curve, and we have got a formula for displacement. So this mouse is doing, he's started here at his hole, he's come out, he's stopped, and he's gone back. Okay, so if you look at the original velocity equation, which is 4t, the factorized form, t minus 3, t minus 6, we can already see that at x is 0, that's here at the hole, that's when time is 0, and he gets back at x is 0 when time is 6. If you look at this equation, if we put velocity equal to 0, that occurs 3 times. In other words, the mouse is stationary when t equals 0, 3, and 6 seconds. Now we know at 0 seconds he's here, so therefore he stops when t equals 3, and then he runs back. So it takes 3 seconds to get here and 3 seconds to get back. So he's stationary, he runs out, he stops, probably frightened, and then goes back and gets back and stops again at 6 seconds. So therefore we need to work out this distance from time is 0 to time is 3. So when t equals 3 seconds, x is, looking at the formula for x, it's 3 squared bracket 3 minus 6 all squared. So we get 9 times -3 squared. So it's 9 times 9, which is 81. So remember, it's going into the formula. Just write that out properly. It's going into this formula, x equals t squared, t minus 6 squared. So we got 3 squared times 3 minus 6 squared. So it's 9 times 9, 81. I think it's wouldn't be meters, it's probably centimeters. Okay, so there to come out, 81 centimeters out, 81 centimeters back in. So therefore the distance traveled equals 81 times 2, so it's 162 centimeters. And what is his average speed? So therefore average speed is the distance travelled over the time, which is 162 centimetres over 6 seconds. So that is 27 centimetres per second. Now, part D, maximum speed. So you have to maximise the speed. Will occur when dv dt equals 0. So we know that v equals 4t cubed minus 36t squared plus 72t. So dv dt is 12t squared minus 72t plus 72. We're going to put that equal to 0. And we've got, so 12t squared minus 72t plus 72 equals 0. Dividing through by 12, t squared minus 6t plus 6 is 0. Can't see factors of 6 that add up to negative 6, so it'll be quadratic formula. T is negative 6, which is positive 6, plus or minus the square root of negative 6 squared is 36, minus 4 times 1 times 6 over 2 times 1. So it's 6 plus or minus the square root of 36 minus 24 is the square root of 12 over 2, which is 6 plus or minus the square root, it's 2 root 3. 6 plus or minus 2 root 3 on 2, which is 3 plus or minus root 3. So the maximum speed will occur at one of those times. Now, the reason we're getting two answers, so the 3 plus root 3 centimetres per second will be velocity in the positive direction when the mouse is running out, and then it'll run back in. And 3 minus root 3 centimetres per second, same speed, but just different direction. Actually, no, we get different values for that, actually. So they're not the same, okay? One of those will be a maximum. We've got to see which one it will be. Okay, so just need to do something else there. So let's do the second derivative. Sorry about that. The second derivative is 24t minus 72. And when t is 3 plus root 3, we get that the second derivative is 24 times 3 plus root 3 minus 72, which is 24 times 3. That's 72 minus 72, which is 0 plus 24 root 3, greater than 0, concave up. Well, that's a minimum. So when t equals 3 minus root 3, the second derivative is 24 bracket 3 minus root 3 minus 72, which is 172 minus 24 root 3 minus, sorry, it's 72, not 172. Take away 72, which is negative 24 root 3, which is less than 0, concave down, therefore maximum. So we get the maximum speed at t equals 3 minus root 3 seconds, which is approximately 3 take away root 3 is approximately 1.27 seconds to 2 decimal places. Oh, that's the maximum velocity, and therefore this one's the minimum velocity. Sorry, I didn't read the question carefully. So the minimum velocity is at 3 plus root 3, which is at approximately 4.73 seconds. Okay, so we've got both those. So the maximum minimum velocities, when they occur, we've got that. Where do they occur? So when t equals 3 plus root 3. You need to see the displacement. X is 3 plus root 3 squared. 3 plus root 3 minus 6 squared, substituting it into the formula of x is t squared bracket t minus 6 squared. Okay, we've got, this is root 3 plus 3 squared, and this would be root 3 minus 3 squared. They're both squared, so it's root 3 plus 3, root 3 minus 3, and that's all squared. Now that's of the format a minus b, which is a squared, which is 3, minus b squared, which is 9. That's all squared, and so it's 36 centimeters per second. No, centimeters. So, centimeters. So the maximum, no, not the maximum, the minimum speed. So therefore, the minimum speed is at t equals 3 plus root 3 seconds, and it's 30, and it'll be at 36 centimeters. Minimum velocity at 36 centimeters outside the hole. When t equals 3 minus root 3, the displacement or position is 3 minus root 3 squared times 3 minus root 3 minus 6 squared, which is 3 minus root 3 squared and negative 3 minus root 3 squared. Now I'm going to write that as negative root 3 plus 3 squared, negative root 3 minus 3 squared, because that can be written as negative root 3 plus 3 times negative root 3 minus 3, all that squared, which now is a difference of 2 squares, so it's a plus b, a minus b, so it's negative root 3 squared, which is 3, minus 9, all squared again, 36 centimeters. So this will be the maximum speed as well, is 36 centimeters from the hole. But one of them would be when coming out and the other one's going in. But these are maximum and minimum velocities. They're actually, it's velocity. That's not speed, it's velocity. Sorry. It just means that this is happening in the negative direction. He's running back. And this is, when the mouse is running out. So you've got the mouse hole, comes in, comes out. This is at 3 seconds. At 3 minus root 3 seconds, he's at his fastest velocity, but coming out in the positive direction. And coming back at 3 plus root 3 seconds, he's still at that maximum velocity, but because it's going in the negative direction, it's called minimum velocity, but it's actually the same speed. Okay, so one's going in, one's going out. That's why the velocity coming out is positive and the velocity going back in is going to be negative. But the same speed occurs at 3 plus root 3 and 3 minus root 3 seconds, but just occurring in opposite directions, okay? That's part D. Now for part E, find the change in displacement and the average velocity. Sorry, once again, I've just read the wrong question. These are the maximums. The maximum speeds occur at those times. Sorry, I was looking at question 19. The maximum speed, I think we already worked it out. Okay. Maximum speed or velocity, or maximum speeds occur when t is 3 plus root 3 and 3 minus root 3. So and it's when it's 36 centimeters from the hole. So sorry, I was looking at another question. So when t equals 3 plus root 3, what is the velocity? The velocity equation is, we've got a few of them, 4 bracket 3 plus root 3, t, which is 3 plus root 3 minus 3, 3 plus root 3 minus 6. So that's when t equals 3 plus root 3. Either one will work. And we get 12 plus 4 root 3, and that will be times root 3 and times root 3 minus 3. So it's 12 plus 4 root 3 times root 3 times root 3 is 3 minus 3 root 3, which is 36 minus 12 root 3 plus 12 root 3 minus 12 times 3 is 36. That's the minimum velocity, 1. Actually, that does make sense. So minimum velocity is 36 centimeters outside the hole. And when t is 3 minus root 3, we get velocity is 4 times 3 minus root 3 times 3 minus root 3 minus 3 times 3 minus root 3 minus 6, which is 4 root, sorry. So that is, multiplying these two, we get 12 minus 4 root 3 times 3 minus 3 is 0, so times negative root 3 times negative 3 minus root 3, which is 12 minus 4 root 3, all of that, times 3 root 3 plus 3, which is 36 root 3 plus 36 minus 9 times 3 is 27. No, 12 times 3 is 36, sorry. 12 times 3 is 36 minus 12 root 3, which is 24 root 3. That's better. So therefore, that's the maximum velocity of 24 root 3 centimeters per second, and it's when t is 3 minus root 3. Okay? Or maximum speed. I need to check that there is no mistake here. So I've got 4 bracket 3 plus root 3, 3 plus root 3 minus 3, so that's a root 3, and 3 plus root 3 minus 6. So we've got 12 plus 4 root 3, and that's root 3, and this is root 3 minus 3. So we've got 12 plus 4 root 3 times 3 minus 3 root 3, which gives us 36 minus 36. Sorry, I made a mistake there. Mistake. Minus 36 root 3. I was a bit worried about that one actually. Thought it didn't make sense. Plus 12 root 3 minus 36 gives us negative 24 root 3. So therefore, that's that velocity. Sorry, I knew that was a mistake. It's the velocity of 24 root 3 centimeters per second, but in the reverse direction. In other words, going back to the hole. Didn't think that made sense. Okay, so just go back and fix that, please. Okay, so we've got the maximum speed at 24 root 3 centimeters per second. At time is 3 minus root 3, 3 plus root 3. Okay, for part E, the change in displacement and the average velocity. Well, the change in displacement is the final displacement minus the initial displacement, which is 0 minus 0, which is 0. So therefore, the average velocity, different to average speed, is displacement over time, which is 0 over 6 seconds, which is 0 centimeters per second. That's the average velocity of the mouse. When you look at 0 time and 6 seconds later, he hasn't actually moved anywhere, or she, it, whatever. And F, sketch the displacement time graph and hence find the distance travelled. I think we already worked that out. Oh, I'm looking at the wrong question again. So maximum speed, really, sorry, that's another question. Really sorry about that. And part E, again, is if a video of these 6 seconds were played back, could this be detected? Well, I think so. In the first 3 seconds, the mouse is running out, and in the last 3 seconds, the mouse is running back. So, not sure what they mean by could this be detected. So first 3 seconds, mouse runs out, stops, and then mouse runs back in for the last 3 seconds. Okay, that's the end of that question.